Video number 8, Chapter 9. Let's move on. Consider the example from the last video testing whether a coin was fair or not. We concluded that the coin was not fair because the p-value, for those that maybe don't remember, but I do, was 0.044. And that was even after doubling our p-value because it was two-tailed. And our 0.044 was less than our alpha value, which we used as our 5%, or 0.05. So we know heads comes up more often than tails as a result, but it does not give us any idea as to what the true proportion of flipping heads is for all instances. Now, we saw in our sample proportion that Count Buffon got 2,084 flips out of 4040, which was approximately 0.515, trying to remember, 3, I want to say. Now, can we use this number to say that the true proportion of heads that comes up is close to this? You know, we really don't know. Now, what gave us a better estimate, basically, of what the true proportion could be was a confidence interval. Okay, it gave us a range that said, you know, we think the true proportion of the number of, not really the number of times, but the proportion of times that a heads came up is between this number at the minimum and this number at the maximum. Now, what I want you to look at is here's the information from the last video. Okay, here was our null hypothesis, or our alternate hypothesis, that our proportion was not equal to 0.5. Here was the z-score we got. Here was the p-value we got. Here was that p-hat. Oh, it was not 0.5153, it was 0.5158, sorry. And here was our sample size of 4,040 coin flips. Now, I also did in the calculator a 95% confidence interval. And I did mention towards the beginning of the chapter that the confidence level and the alpha value are basically complements of each other, that they will always add up to be 100%. Now, whenever we did our hypothesis test, we rejected the null hypothesis. And we really said, yes, the proportion of times heads comes up is not equal to 50%. Now, if I look at my 95% confidence interval, you know, here it is. I believe that this interval is going to capture the true population proportion of the times heads comes up. Now, what we can do is we can use a confidence interval to reach the same conclusion that we would for a hypothesis test. So our hypothesized value was that p was equal to 50%. And the question you have to ask yourself is 50% inside this confidence interval? And you would find out that no, it's not inside there. It's just outside over here. So since 0.5 is not in our confidence interval, we have reason to believe that 0.5 is not really the true population proportion of the times that heads comes up with this particular coin. Okay, so we would also reject the null hypothesis with the confidence interval. So confidence intervals and hypothesis testing can really go hand to hand. Get it? Those are really bad drawings of hands. Anyway, so here's what I just basically answered here. Is the hypothesized value of 0.5 being captured by the confidence interval? And no, it is not. So we would reject the null hypothesis. Now, there will always be this special connection between a confidence interval and a two-sided hypothesis test. Because basically a confidence interval itself is two-sided. It's leaving out, if you will, two sides. The part that's greater than the maximum number and the part that's less than the minimum. Okay? Just like in a two-sided hypothesis test, we are really more concerned about these two ends than we are than what's in between them. And that's why they are complements. Hypothesis testing focuses on the ends, and the confidence interval focuses on the middle part. Now, there is a connection between a confidence interval and a one-sided test, but it's not as clear-cut as it is with a two-sided test. Doesn't mean you can't make a connection, but it's not as straightforward as what you might think it is. Now, the example we're going to look at here. A friend of yours recently got a 73% on his last AP Stats test. He thinks the class average is about the same as his grade. You disagree with his assumption, but honestly have no idea if the class average is really higher or lower than his grade. Below are computer printouts of a 95% confidence interval and a hypothesis test at the 5% alpha level based on a sample of 40 randomly selected test scores from the last test. What conclusion would you make regarding that the mean is 73% versus it's not 73%? Okay, now the reason why we practice looking at computer printout models is because there will definitely be questions on the chapter test and definitely on the AP exam where they expect you to read computer printouts. Because in all honesty, if you were going to have a job as a statistician, which everybody in the world wants to because they make a lot of money, and why wouldn't you want to make a lot of money? Um, in actuality, professional statisticians don't do calculations by hand. They use computer software. So they have to know how to read the output that they would see to interpret it to see if really what they wanted to see is true or what they wanted to see is false. So this first box represents the confidence interval. Okay? So if you wanted to create the confidence interval, here's all the information you need to do it. But here is the confidence interval right here. So the confidence interval, the 95%, goes all the way down to 72.73%, all the way up to 79.67%. And we need to just ask ourselves, is 73% inside this confidence interval? And it is. 73% is captured by this confidence interval. So, can we say that 73% could not be the actual population mean or the actual average score on the AP Stats exam? No, we cannot eliminate it because it is actually a possibility that it is the actual mean score. So in this case, we would, oh, wrong way, we would fail to reject the null hypothesis because it is, again, inside, it is in between these two values. Okay? It doesn't matter how close to one of the ends it is, but if it is actually in between these two numbers, that's all that counts. Now down below, here is the results of the hypothesis test. Okay, and if you wanted to do all the calculation stuff, here you go, knock yourself out. Here's our, technically our t statistic. We haven't gotten there yet, that'll be next section. If this was a proportion problem, then this would say z instead, and that would be our test statistic. But the one thing you really want to focus on more than anything is, here's your p-value. And compare your p-value to your alpha value of 0.05. Well, our p-value of 0.07 basically is not less than our alpha value. So as a result, we would also fail to reject the null hypothesis. Whatever result you see from your confidence interval, you're also going to see from your hypothesis test. They will always match up that way. Okay, so we can't disprove that the mean is not 73%. So we just kind of have to continue to go with it unless we do something else, unless we maybe increase our sample size. We would reject the null hypothesis if we had instead done at a 10% alpha level, because at that point our p-value would be less than, and then we would conclude that the mean is not 73%. But then at that same time, we're increasing our type 1 error, which, maybe or maybe not is a good thing. We don't know. Now, here's the example in the book that you can kind of read through. Again, here's what maybe some computer printout stuff looks like. And here's where it does say z value instead of t, because this is an actual proportion problem. But again, the one thing you want to focus on more than anything is, there's the p-value. That's the main thing you're going to want to look at. And then here is the problem I want you to do and bring the answer to class the next day. Okay? So pause video and do the problem, and you will be done. And then it will be on to video 9. Until then, goodbye.